Advanced features, lecture 2. So we're going to cover some advanced features in part design as well as assembly workbench. Okay, let's take a look at a sketcher. So I'm going to start by modeling this part using Sketcher, which all of you should be familiar with. And then there's a second option called Position Sketch. And I'm going to use Position Sketch to do the slot. Okay, so let's first go to Sketcher and do the profile of this part. Okay, so I'm going to go into Part Design. All right, I'll just do a sketch on the XY plane. I'm not going to constrain it just for time. Okay, so we have our basic shape. Just go ahead and make this one vertical. It did not create there it is, vertical. Okay, so I'll leave the constraints out, dimensional constraints, just to save time. I'm going to exit. Do a pad. Okay, so now I'm going to model the slot. Okay, so let's go back. So we did this one with the plain regular sketch. Sketcher command. Okay, so we use Sketcher command for the basic profile. Now we're going to use Position Sketch to create the slot. Okay, so instead of Sketch, we're going to use, there's a second option, okay, called Positioned Sketch. So I'm going to click on that one. Okay, so this is a position sketch. I'm going to sketch it on this surface. Okay, so let's go back to our PDF file here. Okay, so we did position sketch. We chose our surface. Okay, so we pick a surface, and then we need to create an origin. It needs to know where 0, 0, or the horizontal and vertical axis are going to intersect that. Okay, so I'm going to select this edge and this edge to identify my point of intersection, my origin at 0, 0. Okay, so we're going to create our origin using intersection of two lines. We already did the surface of where we're going to place our sketch. Okay, so once again, as you can see, we already positioned our sketch on this surface. Okay, now we need an origin. So we want to place our origin at this corner. So I'm going to say intersection of two lines. I can also just use implicit. I'm going to go ahead and use intersection of two lines just so I can clearly see my origin. So I want this point, so I'm going to select this line, and there's the intersection point, and you can see my origin of 0, 0. Okay, the next thing we need is orientation. Back to the PDF file. Okay, so now we want to rotate. Currently, in CATIA, it's vertical and horizontal. I want to change the orientation of our axis system. So we're going to go to orientation, parallel to line, and we're going to select this edge so it'll rotate our axis with respect to this edge. Okay, so let's go back. So currently you can see the vertical going vertical, the horizontal going horizontally. So now we're going to change the orientation so it lines up with this edge. Okay, so I'm going to go parallel to line. In this case, an edge. I'm going to pick this edge, and you'll see our axis rotate. 3, 2, 1, select the edge, and there it is, our vertical. Now it's going off at an angle, so is the horizontal. And the vertical is now perpendicular to the edge, and the horizontal is now parallel to the edge. Okay, so once I hit OK, it'll go into Sketcher. And notice how it rotates the part with respect to our vertical and horizontal axis for our sketch. Okay, so it rotated the part, so it just makes it easier for us to model our, in this case, our slot. So I'm going to go ahead and model the slot. And I can just put some dimension between the edge and the slot and add more constraints. It just makes it easier modeling the slot in the horizontal or vertical, in this case horizontal. Okay, so once we constrain it, it's green, we exit, and now we can go ahead and do the pocket. And there's our slot. Okay, so if we would have done a regular sketch, notice this is a position sketch. If we would have done a regular sketch, let's go back to regular sketch. And we would have selected the surface with regular sketch instead of position sketch. Look at what would have happened. It would have not given us the orientation we wanted as we had it earlier, right? So we would have to model a slot at an angle. Just easier if we model it in the horizontal as we did in sketch 2. Okay, so that's position sketch. Let me just exit, go back to where I was. So once again, this was position sketch. We can sketch with respect to our axis, which was rotated. All right, so let's go on to the next slide. All right, some of you may want to increase the size of your planes or axes. Okay, so if you want to change the size of your planes, go to Tools Options, go to Infrastructure, Part Infrastructure, go to Display, and you can slide the bar to change the size of your planes or axis. Okay, as you can see, currently my planes are small. I'm going to go to Tools Options to change the size, Tools Options. Okay, I'm going to go to Infrastructure, go to Part Infrastructure, go to Display, and currently my axis and my planes are set to 10 millimeters in size. I'm going to increase it. I'm going to exaggerate and go something large and hit OK, and you'll see my planes increase in size, and OK, and there's my planes. Some of you prefer larger planes. And if I had an axis, it would also increase the size. Later on, we are going to insert an axis. All right, let's go to the next slide. Okay, as you can see, my part doesn't have an axis. You can insert one manually if you like. Here's the axis, but we'll cover that in a few minutes. Let's say anytime you start a new part from scratch, a new part, and you want an axis inserted automatically, it always inserts the X, Y, Z planes automatically, which you cannot delete. So you can see I can right click, the delete is grayed out. You are not allowed to delete your X, Y, Z planes. Now you can insert an axis automatically by changing your settings. So let's go back. So anytime you start a new part from scratch and you want an axis automatically inserted, you can turn this option on. The default for CATIA is to have it off, but you can turn it on. And we're going to go back to Part Infrastructure. And instead of Display tab, this time we'll go into Part Document. Okay, so let's go back. Let me dock this back into place by double clicking. Drops it back. Okay, so let's go to Tools Options again. This time we'll go to the Part Document. So once again, we are in Tools, Options, go to Infrastructure, Part Infrastructure. This time we'll go to Part Document. And we can say, hey, anytime you start a new part, we want you to create an axis system. At 0, 0, 0, where all three planes intersect. And OK. So if I was to start a new part from scratch, Part Design. Okay, so we're doing a new part. It'll automatically bring in an axis. It'll hide the plane so it doesn't overcrowd, but you can always unhide. When you see grayed out, that tells you it's hidden. By the way, we haven't talked about this, but if you want to see what's in the background hidden, you can swap. So this is the background. This is the no-show layer. Okay, so these items are hidden. You can tell by the green background we're in the no-show. If you want to go back to the visible, this is the visible layer. Okay, so I can always unhide. So I'm unhiding the planes, as you can see. All right, so let's go back to our part. I want you to notice also that anytime you use a sketch to make a pad, a pocket, etc., it'll automatically hide the sketch. See how the sketch is grayed out? It didn't go away. It's in the background. Once again, if we go into swap, there's our sketches. It's in the no-show layer. You can tell by the green background that we are in the no-show layer. We can go back to show. All right. If you want to hide something, here's the key. Here's my mistake, the icon to hide. If you wanted to hide your planes, for example, hold on to the control key and you can hide them. Or you can, once again, select them, hold on to the control key to select more than one item, or you can right click, hide show. Notice it's the same icon. There it is. And once again, you can swap back and forth to see what's in the shown and what's in the invisible layer. Okay, let's go on to the next slide. All right, so let's talk about, we'll come back to manual update. Let's talk about axis system. So currently I don't have an axis system in it's there, but we just don't see it. It's the intersection of the XYZ plane. But if you want to insert an axis, so we can go, let me go ahead and drop that back in place. And let me take out the toolbar we're discussing right now, which is the tools toolbar. All right, so if you want to insert an axis, click on axis. Notice it automatically drops in an axis at 0, 0, 0. You can always move it if you like. Okay, so you can place it in a different location, and I'll come back later and show you how to locate or insert a new axis. Okay, hit OK. And I want you to notice it adds your axis in your axis system branch. You know what? Let's go ahead and insert a new axis. I'm going to insert an axis up here at this corner. So I'm going to go axis again. I want you to notice it inserts a new axis system. So it's asking me for the origin. Hey, I'll place it up here. And let's say I wanted to flip it so that the X went in this direction. So if I want to put the X in line with this edge, I can click in the X window, click the edge, and see now the X goes in the same direction as the edge. I can flip it, I can reverse it. There it is, reverse. Okay, if I want to make this the Y instead of the Z, then I'll go to the Y axis window, make sure it's blue, select the edge, and notice how it changes the orientation of my axis. And once again, you can flip it by going reverse. If you want positive to go in the opposite direction, click reverse, and there it is. Okay. So that's how you insert another axis. Sometimes you want to create a second axis to model some type of pattern, maybe a whole pattern with respect to that axis and not the default axis. All right, let's go on to manual update. Okay, manual update, typically you just leave it off. If you turn it on, it'll turn orange if you click on it. Okay, so let me show you a manual update. Most of you will never use this. So manual, there it is. It's orange, it's active. So let's go ahead and make a change. I'm gonna make a change to the slot. I'm gonna add a hole. So I'm gonna go back to sketch 2, double click. Misclicking here, there it is, okay. So let's say I wanted to add a hole. So we already have the slot, and let's say we wanted to add a circular hole. So I'll add a hole. I'm gonna exit. Okay, so now it wants to update. Notice how it stays red. You saw that I added a circle, but it doesn't update. That's because we have manual on. So then you have to manually click the update button for it to update. So In 3, 2, 1, manually update. There it is. Now it updates with the hole. Okay, so typically you'll have this manual update off. Okay, it's off. The only time you really want to have it on is when you have a bunch of features. There's a bunch of features. I'm talking about dozens and dozens of features. And if you change something at the top of the branch and it's going to affect everything, that it's going to update everything below it, it may end up causing your CATIA software to freeze or computer to freeze because it's trying to update a lot of things in one shot. So that's the only time I've used it. I rarely use it unless I have a long string of features, dozens of features, that if I make a change at the top, it's going to affect everything. It's going to try and update everything, and it may end up jamming or freezing. So then I'll do it manually. Okay, so it doesn't update all in one shot. All right, let's go on to the next. Okay, we have disables tree branch. Okay, so let's go in. Sometimes you'll have more than one part body. So sometimes you'll download 3D models from a hardware catalog online, like McMaster or Carlane. You'll be downloading bolts, nuts, clamps. You're going to be downloading common stuff that you see in a machine shop or a metal forming shop. You can download these models of the parts that they sell, and it comes in as a bunch of part bodies. Okay, so let me show you an example. I'm going to insert a new part body. So let me change this gray part body, give it some color, right click properties, give it some color. So sometimes when I download something from a catalog, or maybe I have to model something from a catalog that we can order for a machine shop or metal forming shop, like clamps, for example. When you download it, it'll come in separate part bodies, or if you're modeling it on your own based on their dimensions in their catalog or their website, instead of having to model different parts, I'll just do one part with multiple part bodies. Okay, so let's say there's something that inserts into this hole, like a shaft. And when you order the part, it comes all together as one. All right, so I'll insert a new part body. So now I have body 2. All right, so if I want to model something in the part body, I'm going to right-click Define. Right-click Define, and it'll underline it. It's already defined, it's underlined. If I wanted to make changes to the first part body, I have to right-click Define, and it'll underline it, so it knows any features I'm using, like chamfer, fillet, hole command. It'll apply it to this solid. Okay, so let's go back to part body 2 because we're gonna insert things into this part body. So let's right click Define. Okay, so I'm gonna make a sketch on this surface. Let's say there's a piece that inserts here. And I'm gonna go ahead and just project it. Instead of drawing a circle, I'm just going to pick this edge and I'm going to project it. Okay, so projects the circular curve. Okay. Click and space to deselect. There it is. There's my sketch. Exit. And I'm going to do a pad. Let me make it 50. Notice it's a different color. These are separate pieces. So we have the shaft. Let me give it a color. Right click properties, go to graphic. I'll make it green. There it is. Okay, so these are two separate part bodies. So we have the part body 1 and body 2. So if I wanted to insert a hole in this part, I'm going to right click Define the second part body, right click Define. If I want to put a hole on that part, click on Hole command, and it'll add the hole to this part. If I hit the plus sign, you can see there's the hole. Now, if I wanted to do a chamfer on the blue part, on the blue solid, then I have to right click Define. And let's say I wanted to add a chamfer on this edge, or a fillet. You know what, let's go ahead and do a fillet. Fillet on this edge. And okay, there it is. Now you can have multiple part bodies and it may end up getting crowded. Okay, so let me go ahead and insert another third body just to crowd it up a little bit. So I'm going to insert another part body. You can have as many as you want. And I'm going to put its opposite of this slot. I'm going to model its opposite. It's negative. I'm going to do a sketch. Make sure you right-click Defined so it's underlined. Sketch on this surface. Okay, so I'm going to go ahead and project. I'm going to hold on to the Control key and project the edges of the slot. Okay, let go of the Control key and project. Projects all 4 elements. Click in space. Oh, hit OK. Now I click in space to deselect. No longer orange. I'm going to go ahead and exit and do a new pad. I'm going to reverse it. Okay. Okay, so notice these are different part bodies. And again, when you download something from Carlene or McMaster, sometimes you order clamps that has multiple parts and it comes in with a bunch of part bodies. Instead of giving you an assembly, it's just a lot simpler keeping it as one file. Okay, so let's say I wanted to do more stuff to the blue piece. And I wanted to turn these off. Instead of hiding them, what I can do is go to the blue piece, right-click Define, make sure it's underlined. If I go back to the lecture notes, if I turn this on, it'll turn off any other part bodies or geometric sets within it, and it'll only keep on the one that's active. Okay, so currently the one that's on is the blue, or the one that's currently active is the blue piece. It's underlined. So watch what happens when I click on only current body. 3, 2, 1, click. And what it did, it just placed the other ones as, think of it as dormant. It's ignoring it. Yeah, it's still all there, but it just hid it from us, just so the screen doesn't look crowded and I can continue doing more work. I don't know, maybe I want to add a hole, and I don't want the other pieces to be in my way visually. So, and once I'm done, turn it off. A lot of students will forget to turn this off. You'll save your work and then come back the next day, open up the file, and it's like, oh, where's my other pieces? So just, there it is. Turn off this option, it'll bring them back visually. All right. Okay, finally we have the hardware catalog. So on your assignments, you either have the option to use the hardware, bolts, nuts, and washers that I email you. You can model your own hardware. You can download it from McMaster.com, Carlene.com, or MSDirect.com. You can look up fasteners, bolts, and washers there. And you can download their 3D models. You can download them as step files, IGES files, or CATIA if they have CATIA. Okay, or you can go into the CATIA catalog. In the old days, it was cool to use the CATIA catalog, but nowadays most people just prefer to download it from McMaster or Carlene. The CATIA catalog is limited. Yeah, so before we had access to internet, you would just go to the catalog and download hardware. So let me show you how to download hardware. Okay, so first you need a assembly. Okay, so I'm going to go to the assembly workbench. Okay, so go to assembly workbench in order to download hardware, bolts, nuts, etc. Okay, so here's the catalog. Click on catalog. All right, so let me go to the default. So I'm going to go to ISO standards. There's also American standards. Let's go to ISO standards. Okay, I'm going to go to the international standards. I'm going to zoom in here. So I'm going to click on the wheel, tap on the right button and let go, but hold on to the wheel so I can zoom in, just like a 3D model. If you want bolts, double click on the bolts. Double click again. I'm misclicking here. Okay, let me zoom in again. Okay, what type of bolts do you want? Do you want a grade A, B, hexagon, head bolt, and it gives you a preview. Let me just go with the first option. Double click. It gives you a list of metric. So anytime you see M in front of a number, that's telling you they're using the metric system. 3 stands for 3 millimeters in diameter, 5 millimeters in diameter. So here's the diameter, as you can see, and the diameter is in millimeters. Okay, so if I wanted to download an M5 5 millimeter diameter bolt with the length of 25 millimeters, double click on it, and it'll load it into your assembly. So you can see, there it is. It loads it in. Okay. Now let's say we wanted to bring in a nut. Okay, so let me go back, go to ISO standards. And again, we also have American and Japanese standards. Go to ISO standards. Let me zoom in and double click on the nuts folder. Double click. Okay, I'll use a hex nut style 1. There it is. It gives me a preview. Double click. Oh, got to double click from up here. Double click. There it is. Okay, so I'm going to look for an M5 because that's the size bolt that I used, an M5. Okay, an M5, so 5 millimeter. So the diameter is 5 millimeters, and it doesn't model the threads because the threads, so this is a tapped hole with threads, but we don't model threads because it eats up a lot of memory. If you include threads on a nut or on a bolt, this file can be 10 times larger than without threads. Okay, so that's the reason it doesn't give us the threads to save memory. Okay, so let's double click. There it is. It brings in the nut. And let me go ahead and exit this, close it. And I'm going to use the compass here. Drop it on a flat surface, or you can drop it on an axis by dropping it on a cylindrical surface or conic. And I can just move these apart. Let me reset my compass, reset compass. Once you're done using it, you should reset it. There it is. Okay, notice there's no threads. Again, it's so it doesn't eat up memory. Okay, so this is a hardware catalog built in CATIA. When you download CATIA into your computer, it should have also downloaded the catalog. But once again, chances are I know when I worked in tool design, I always downloaded my hardware from McMaster or Carling. Okay, go check out their website. Pick the bolt or nut size that you need, or washer or other hardware, and typically it'll have there's a 90% chance that it'll have a 3D model that you can download, whether it's a step file, IGES, SolidWorks, CATIA. There's other options also. Okay, let's do some transformations. All right, so this is transformations at the part level, not at the assembly level. Okay, if you go to the pull down here, it'll give you more options. You can translate, right? You can rotate, you can mirror, or you can move things with respect to axes. So one axis to another, looks like chicken feet. Okay, so let's play with translations first. I'm going to go ahead and close this. All right, so let's say I wanted to translate this body 3. Let's say I want to translate it and slide it upward. First, I'm going to right-click Define. Let me go ahead and double-click on this toolbar and send it back to where it belongs. All right, so we're going to take a look at translations. Okay, so this is a transformation toolbar. By the way, by holding onto the Shift key as I move the toolbar, so I left mouse, grab it by the handle. So there's these little handles. See, for example, this one, you can grab it by the handle, and if you hit the Shift key, it'll change its orientation from horizontal to vertical or vice versa. You can drop it in. Okay, so I'm going to hold on to it, click on the Shift key to change its orientation. And if I go to the drop down here, you have more options. Okay, so let's take a look at translation. Okay, so I'm going to translate body number 3. So right click define, and it'll underline it, letting me know it's going to make changes to this piece and not the other two. So let's say I wanted to translate it upward. So click on translation. And it's just giving me a warning. Are you sure you want to do this? Yes. Okay, so give it a direction. So I can say, hey, I want to go vertical. I can pick an edge to give it direction. And I can use these green arrows to slide it. Or I can type in a number. So I'm going to just slide it using these green arrows. I know that these are hard to see, but there's these green arrows that you can pull on. And it translated this part by 40 millimeters. And okay, there it is. I can go back and show you that translation. There it is. Now let's say you wanted to throw it back, bring it back down, but you wanted to keep this translation for future use. So maybe this is in the up position and you can push it inward so it ends up flush with the top of the blue block. Okay, so let's say you wanted to keep this translation, but you wanted to push it back down, but you don't want to delete the translation. So one thing you can do is deactivate it. You can turn it off without deleting it. So you can deactivate. 3, 2, 1, deactivate. I think I misclicked. Let me cancel. We'll try it again. Right click. Deactivate. There it is. Right, I did misclick the first time. So notice it turns it off. It sends it back down. Notice these red parentheses. It basically has deactivated this feature. Okay, so it's basically ignoring it. If I wanted to reactivate it, I just got to right click and reactivate or activate. 3, 2, 1, activate. And there it is. It turns on that feature. Okay, so that is translate. Okay, now let's take a look at the next one, rotation. Okay, so let's say I wanted to rotate one of the solids. You know what? I'm going to go ahead and rotate the same object. Okay, so right click define body 3, right click define in work object. And I'm going to rotate it about this edge here. Okay, so I'm going to rotate. Are you sure? Yes. I'm going to rotate it about this edge. Okay, so I'm rotating the gray solid about this edge. Use that as my axis. You can see it gives me a preview. I can pull on the arrows, or I can type in an angle. I'm going to type in 90. And okay. And there it is. And once again, you can deactivate it. You can turn it off. Right click. Deactivate it. Sends it back. It just turns off or deactivates this feature. We can reactivate it by going right click, activate. All right. Let's take a look at a different feature. Let's take a look at symmetry. So we have these two are different. One is symmetry, one is mirror. One will keep the original solid. The other one will mirror it, but get rid of the original. In this one, it'll create a new one and keep the original. Okay, so let's take a look at both. Okay, let's do the first one. So let's say I wanted to make a copy of the cylinder over here to the right. Okay, so I'm going to first define body 2. So the green cylinder is body 2. Right click define. Okay, notice it's underlined. And if you want, you can give it a name. You can right click properties and call it cylinder. Okay, and so on. Right click properties, call it plate for the first part body. All right, so I'm going to do a symmetry of the green shaft. I'm going to do a symmetry. Are you sure? Yes. And I'm going to pick this XZ plane. on this axis. Click it. Gives me a preview. And by the way, it's gonna hide the original one. In 3, 2, 1, okay. So it hides the original one. Let's go to part body 2. You can see there's the symmetry. I can always deactivate it like we did the other ones. Deactivate that feature. And we can always reactivate. Okay, so that was symmetry. Let me go ahead and delete it and we'll do mirror. Delete. Okay. Okay, let's do a mirror. Okay, so mirror is this option. Go back to CATIA. Okay, instead of using this one, we're going to go to this one here, mirror. And let's once again do the second part body. Right click, define, body 2. Do mirror, and we'll choose the exact same plane. By the way, you can also pick the surface. I'll pick the surface as long as it's planar. Okay, so it's already making a copy of it. It's already making a mirror image of it, but it'll keep the original one. 3, 2, 1, okay. Okay, so it'll keep the original one and create a new one. I'm going to go ahead and delete it. Okay, so let's move on. Now let's take a look at these axes. Looks like chicken tracks, chicken feet tracks, okay. So in this case, we're going to move from one axis to another. Okay, so let's go back. Okay, so what I'm going to do is I'm going to move this gray piece with respect to this axis to this one. Okay, so we have two axes. Okay, so let's go back to this slot, or to this solid. Right click, define, body 3. Okay, so here we go. We're going to move it. But before I do, let me change the orientation. Notice how Z is going in this direction, Z is going in this direction. I'm going to change the orientation of this axis. I'm going to double click. I'm going to change it so that this direction is Z. Okay, so I'm going to go to Z. I'm going to make this one Z. Oh, let me first deselect Y. I'm going to clear Y. I'm going to right click on Y. And there should be a remove, no selection. There it is, no selection. So Z, I'm going to change Z to this edge. Okay, there it is. Z is pointing in this direction. Okay. I just want it to go in the same direction just so you can see what happens when you go from axis to axis with a different orientation. Okay, so right click, body 3, define, and let's use the chicken footprints. Axis to axis. Are you sure you want to do this? Yes. So I'm going to go from this first axis to the second axis. Notice how it changes the orientation. So it moves it and rotates it with respect to the new axis, and okay. So it takes it from this position and translates and rotates with respect to this axis. Okay. All right, so let's go on to the next one. Okay, let's take a look at a rectangular pattern. Okay, so rectangular pattern, and then we'll take a look at circular and user pattern. All right, so I'm going to define the blue plate. Right click, define. So I'm going to make changes to that blue plate. And I can just hide body. Instead of deactivating them, I can just hide them. I'm going to hide them. As you can see, they're grayed out. I right click, hide. I can always right click, show. Okay, I'm going to remove these holes. Let me delete these holes. I'm going to create a new hole pattern. So I'm going to right click, delete the hole, and delete the third, hole 3. Okay, so I'm going to do a hole pattern. So I'm going to create a hole here. I'll make it small. Let's go with 5. Okay, so let's say we have this hole and we want to make a rectangular hole pattern. Okay, so I'm going to go with rectangular, but first I'm going to pre-select the hole. First, let me go part body define, because we're making changes to the blue plate here. Right-click define. Okay, we're not doing the changes to the other part bodies. Okay, I'm going to pre-select the hole, and I'm going to do a rectangular pattern. Okay, rectangular. Okay, number of instances, you got to include the original. So let me increase it to 5. Number of instances, and I need to give it a direction. So I'm going to go to direction. I'm going to go in. I can either pick an edge, I can pick a line. Okay, so it's giving me a pattern. It's going in the wrong direction. Let me hit reverse button. Okay, there it is. So I have 5, including the original. 1, 2, 3, 4, 5. And I can reduce the spacing. Okay, there it is. And it's at preview. And there's my hole pattern. Equally spaced. You also have more options. You can go spacing and length. You can go unequal spacing. Okay, so you have more options. I'll just keep it at instances and spacing. 5 instances with equal spacing of 15. Let's go ahead and add another one. Let's make it 6. And preview. Okay, let's say we also wanted to go and add another row of holes. Okay, so now I can go to the second tab, second direction. So right now there's 1 instance. Let's go with the second instance. I'm going to increase it to 2. And I need to give it a direction. Okay, so I'm going to click on direction, window, here it is. And I wanted to go vertical. Okay, let me pick this edge. Okay, there it is. It's going in this direction now, this vertical direction. I can click reverse. I'm going in the wrong direction. And let me reduce the spacing. Let me go down to 10. And preview. Okay, so that's for a hole pattern. And by the way, if you wanted to remove one of the holes for some reason, you can click on the orange dot and it'll remove that hole. Watch when I hit preview, it removes it. If I want to bring it back, I can click on the dot, the orange dot, and preview, and it'll bring it back. So you can remove a bunch of them if you like. Just click on the little orange dots to remove, preview. Okay. Okay, so that's a hole pattern there using the rectangular pattern. Okay, let me go ahead and delete this. We're going to go with circular now. Actually, you know what? I'll leave it. I'll just put a new hole around this larger hole. Okay, I'm going to do circular pattern. The next one, circular. But first, let me add a hole near this one, this larger hole. Okay, let's say we wanted to do a circular pattern. Okay, so make sure the part body, the blue plate is defined. I'm going to pre-select this new hole I just created, and I'm going to go with a circular pattern. Circular. Okay, let me first pick the direction. So I need a rotation. I need to be able to rotate it. Let's see if I can select the axis. I don't know if it'll recognize the axis of this cylinder. Oh, it does. Okay, good. So I clicked on the cylindrical surface and it recognizes the axis. And there it is. Hit preview. So there it is. We're doing a circular pattern. Let's increase the number. And preview. I can increase the angle. Preview. So this is a circular pattern. Let's go to 90 degrees and okay. So I did a circular pattern. Okay, and finally, let's do the user pattern. Okay, user pattern, you do need a sketch. So I'm going to create a sketch on this surface. I need a sketch with points. Okay, so I'm creating a sketch on this surface. So I'm going to just put a bunch of points in space. So I am in Sketcher, and I'm going to put points. Let me double click so I can add multiple points. So by double clicking on the command, I can add a bunch of points, as you can see. Okay, I'm going to go ahead and exit. So there's my points. I don't want them as construction elements, or else it'll just show up as dots instead of the little crosshairs. Okay, you want it at standard. If you change them to construction, it'll show up as dots and you will not see them when you exit the sketch. Okay, so let's go ahead and exit, and you should be able to see the dots. There it is. There's the dots for my sketch. Okay, there's the sketch, sketch 11. Okay, so once again, let's right-click Define Part Body. Define it. I'm going to first start by adding a hole at this point. Click the surface, and there's my first hole. Hit OK. Okay, once again, we're going to use this pattern created in Sketcher. Let's go back and define your part body. Okay, so I'm going to select the hole. Select the hole. This time I'm going to go with user pattern. Okay, user pattern. And I'm not going to go rectangular. I'm not going to go circular. I'm going to pick my sketch with the points. And it's going to put a hole through every point in that sketch. And OK. Now the cool thing is I can always go back to sketch. And I can add or remove points. Now I cannot remove this first point because that's where I placed my first hole. So I cannot touch this point, but I can make changes to the other ones. I can add more points if I want, and it'll add more holes. I can remove points. I can delete points. Okay, then it'll change my pattern to match the sketch. In 3, 2, 1, exit. And notice it changed the pattern based on the points in the sketch. Okay. Okay, so that's user pattern. All right, so let's take a look at scale and affinity. Okay, let me turn on the others. Okay, let's say we wanted to change the size of the cylinder. So we wanted to scale it up or down. Okay, so I'm going to right click define the green cylinder. And I'm going to use scaling. Okay, so I'm going to scale it. It's asking me for a reference point. Let's see if I can pick this point here. Okay, it looks like I was able to. And then we're going to scale it with respect to that point. So I'm going to increase the size. As you can see the preview. So I'm increasing it by 2.16. Let me type in 2. I'm going to double the size of it. And 3, 2, 1. Okay. And by the way, you did need a reference point. That's why I chose this point, a reference point, and which direction to scale it from. And okay. There it is. It's double the size. So we scaled it up by 2. You can always double click on ratio here and change it, let's say, to 3 times the scale. Okay. Let me change it to half scale, 0.5. Okay, made it a lot smaller. Notice how it scaled it with respect to this point. Okay, so let me go ahead and delete that scale. I'm going to delete it. It should go back to normal. There it is. Okay, let's say now we want to only scale it in one direction. So we're going to use affinity. the second option. But before we do, let me define the cylinder. And I'm going to go with affinity. That allows you to control the scale in any direction you want, or all three directions, X, Y, Z. Okay, I'm going to pick the origin. It's asking me for an origin. So I'm going to use this as my origin. So you can scale on the X direction. Okay, so for the X direction only, watch, I'm going to go double in the X. So you can see I'm only scaling it in the X direction, and okay. Let's go back. Let's say I want to scale it in the Y, 3 times the size in the Y. Okay. Let's say I wanted to make it shorter in the Z. Double click, go to Z, and let's make it 0.5. Okay, so you're scaling it in all directions, and you can use a different number as shown. Okay, so that's affinity. Now the question is, when do you use scale or affinity? The times I use scale and affinity is when creating molds for sheet metal forming. Actually, more for composites. Sometimes you do have to do it for sheet metal, but typically you have to do it in composites when you're laying up carbon fiber or fiberglass sheets. So a good example is, here's a good example, something I helped out with. So this belongs on an aircraft. This is the dash of an aircraft, small aircraft, and we were going to make a prototype out of fiberglass. So one of the young engineers modeled it, and I just had to go in and fix it up so we can actually be able to manufacture it. And I created this mold shown in blue. Now, one of the things is, because it's prototype, experimental, we're going to use some cheap tools or cheap material. This is blue block. It's like a very hard plastic. So what the tech is going to do is take sheets of fiberglass or carbon fiber and just lay it up on this tool. Lay it up. And we can just let it dry up on its own with the resin. Or you can stick in it in autoclave, or you can heat it up. It'll speed up the process and also give it a stronger bond. Okay, so the problem is when you stick this in an autoclave or small oven, or you heat it up, the mold will increase in size due to the heat. So when you heat this up overnight, and the next day you take it out, the piece is going to come out larger than you want, because the mold, due to the heat, it increased in size due to the high temperature. And then when it dried up, the piece came out larger than expected. So you have to change the scale. And typically we would reduce it by 0.02%. So I would change the scale from 1 to 0.998. So we would model this in the 100% size, the actual full scale size at 100%. And then at the end, we would do a scaling of 0.998. So we would scale it down so it was 99.8% the size of the actual. So when it would increase in size due to the heat in the autoclave, it would actually increase to the full scale, and the part would not come out larger than needed. Okay, so that's where you use scale. Also with sheet metal, sometimes when you have to form a flange, like this flange here, there's this thing called spring back when you try and form a piece of sheet metal. So it gets this angle here. Sometimes it springs back. So sometimes you have to change the size of this wall, or scale it so it'll overshoot, and then when it springs back, it'll actually spring to the position you want it to. Okay, so that's scaling. Okay, let's go to anchor constraint. Anchor constraint has a really nice feature. Let me go ahead and open up one of your assignments. Okay, so this is one of your assignments. It's extra credit, the lift assembly. Let's say I had to model a third part. Let's say I had to model a part that attaches here. Okay, so I'm going to insert a new part. into my assembly. Do I want to position it? No, let's say I wanted to respect the coordinates of this clamp assembly. Again, this is what you would do on an aircraft. So as an example, one of our young designers, I modeled a rudder for an aircraft, and for the prototype, and one of our young designers, engineers, was going to model the final rudder for production, where we're going to make hundreds of them. And this young designer accidentally moved the rudder out of position. So let me simulate that. Let's say, imagine this is an aircraft and you had to model a rudder. So let me simulate what happened. So I'm going to sketch on the YZ plane. Create a sketch. Well, first I need to double click to go into part design. Double click on it. There it is. We're in part design. I'm going to click on the YZ plane and I'm going to make my sketch. And imagine you're modeling the rudder for the aircraft at the tail section, obviously, or at the empennage section. And just to save time, I'm not going to fully constrain it. Okay, so let's say that's the rudder and then the aircraft. And exit, and let's go ahead and do a pad. I'll go 5 millimeters in each direction, mirrored. Okay, so let's say this is the rudder of the aircraft. So here's what happened. The student, or I should say the intern, our young intern, modeled the rudder and forgot to anchor it. Forgot to put a constraint. Typically, when you model something, you can leave it alone, but to be safe, you can add an anchor. Okay, so here's what happened. Let's go back to the assembly level. So we're at the in the assembly workbench. So here's what happened. The young designer had the compass active. Let's say this designer was moving something and forgot that the compass was active. Forgot to reset the compass, accidentally clicked on the rudder and slightly rotated the rudder like 0.1 degree. I'm going to exaggerate and go like 10 degrees. So the young designer accidentally moved it out of position, out of context. I'm going to reset the compass, view reset compass. And somebody in one of the other departments in charge of the controls, so the push rods that push on this rudder, imagine like a door. It'll have 3 hinges, like a door of your house or a door on a classroom. So the designer that was doing the controls, the rods that it goes to the pedals and the handles of the pilot, notice that the rudder was out of place. So the young designer panicked and didn't know how to fix this. Didn't want to have to start over from scratch. So the simple fix is to add an anchor. First, you ask the designer, did you model it in the right spot? Yes, I modeled it in the right spot, but I accidentally somehow moved it. All right, no problem. Okay, so we're going to anchor it. So we're going to add an anchor constraint. Make sure you're at the assembly level, and we're going to anchor the rudder. Anchor it. Okay, there it is. We added an anchor to the rudder. Okay, so let's go back to the notes. So, if you model something in context in the right spot like we did with the rudder, and you add an anchor constraint, it'll automatically anchor it at 0, 0, 0 with respect to the coordinates of the aircraft coordinate system. If you accidentally move it, these numbers will be changed. And one thing you can do is update it. You can zero these out and update it. You click on more, zero everything out, and update. Okay, so let me walk you through that. So once again, let's say you move something out of context. You add your anchor. You double click on the anchor. Okay, you're going to click on more, and everything should be zero out. Okay, so click on more. Notice how things are not zeroed out. It's because we accidentally moved it. So Here it's telling me how far it's off with respect to the x-axis, the y-axis, and how much it rotated. So all we have to do is zero these out. So I'm going to type in 0 for x, 0 for y, 0 for z, 0 for the x, for rotation about the x-axis, 0 for about the y, and 0 for about the z-axis. So 0 everything out. Hit OK. And notice the anchor wants to update. Now you can right-click Update or simply click on the Update button. Either one will work. I'm going to right-click, update the anchor in 3, 2, 1. Keep an eye on the rudder and update. And places it back where you modeled it in context. Okay, so that's how you fix it. So if we double-click the anchor, it should all read 0, 0. Click on More, and it does. Everything reads out at 0, 0. It's in the right position, as it was modeled in context. All right, let's go on to the next topic. Here we have a snap option. We have manipulate. We have explode. And later on, we'll do a clash report in a later lecture. Okay, so let's take a look at manipulate, snap, and explode. I'm gonna go ahead and open up the clamp assembly. I want you to notice it didn't bring the hook clamp when I opened it. Let me tell you what happened in this case. It's giving me an error message. Let me go ahead and open this up. Let's see where the error is. Okay, here's what happened. So I reopened my top clamp assembly, which some of you already worked on or are currently working on. Remember the hook clamp that attaches here? It's telling me here, hey, we can't find it. We can't find the hook clamp, so this is the part number. And the reason is because I gave it a new name. So one of the things I did is I went to my flash drive and I went to that file and I gave it a new name. And now CATIA doesn't recognize it. It's like, hey, I don't know what happened to this part. So this is called a ghost file. It can't find the file. It was able to find the other files, but this one, see how it looks like it's ghosted out? So this is referred to as a ghost file. It turns white. So you can go to desk here, or you can go to start. My mistake, go to file desk. Either one will take you to gives you a tree of files and the links. Click on desk. Okay, so it's telling me anytime you see red, it tells you that, hey, we lost this file. We can't locate it. If you see white, everything was linked. Most likely in your flash drive and the folder in your flash drive, it linked it. If it's black, it means it's dormant. That's when you have cache mode on. Remember we talked about cache in a previous lecture? Okay, so this is red, letting me know it can't find it. Let me zoom in. So I'm going to right click and find it. And the reason is I changed the part number on the file. Go to find. I'm going to go find it. And what happened is I renamed it to hook clamp. So there it is. I gave it a new name, hook clamp. And when I hit OK, I actually hit open. It'll relink it. As you can see, it turned white, letting me know it relinked it. If it doesn't like it, it'll reject it. So think of it as finding a substitute for it, and it did accept it. Okay, so now when I go back to my clamp assembly, go to Window, Clamp Assembly, you'll see it's loaded now. There it is. There's the hook clamp. And it's no longer a ghost file. We added color to it now, letting us know it's linked. Okay, so let's take a look at some of the other commands. Okay, so manipulate. Some of you probably already know how to use manipulate. Let's take a look at manipulate and snap. All right, so manipulate allows us to move things. Let me collapse this. So if I manipulate, Let's say you wanted to go in the X direction. Okay, so X direction is active. So if I grab onto this assembly and just left mouse click and drag, I can move it in the X. I can move it in the Y. Click on Y, move it on the Y direction. So it's moving the entire binder. So again, think of this as a backpack, the top clamp assembly, and this is a binder made up of these components. Okay, now the brown strap, it's by itself. It's not inside of a binder. I can also move that if I like. In the Y direction, I can go into Z. I can also rotate. My mistake, move it about, translate it about a plane. Let's go the XY plane. So I can slide it about the XY. And I can rotate it about an axis. Notice it's rotating at about the axis, x-axis. Okay, so you can rotate. Okay, I'm going to hit OK, and I'm going to hit Update, and it should all go back to its original position if I constrained it correctly. Update, and everything goes back to normal. Okay, I can also use Snap. Okay, I can snap from this axis to this axis, for example. Snap it. There it is. And you can flip it if you like. Oh, I misclicked. Let me go ahead and snap the next one. I can snap from the axis of this one to the axis of the slot here. There it is. When you're done, click in space. Okay, you can also do a snap face to face. So let's say I wanted to snap this face to this one. See, it snaps it, and I can also flip it by clicking on the green arrow. Okay, you can also snap point to point or edge to edge. Let me snap, so to exit, let me click in space to exit. I can snap edge to edge. So you can see edge to edge. I can flip it by clicking on the green arrow. Oh, I misclicked. So you can flip it by clicking on the green arrow. And you can also snap point to edge, point to surface. So it's not limited to axis or edge to edge or surface to surface. All right, let me hit Update. If it's constrained correctly, everything will go back to normal. All right, so the next one is Explode. So when I open your files, so when you save your files and email them to me, just to check if you add all your constraints, I'm going to use Explode. Explode command, it'll send things flying out into space. Okay, it's giving me a warning. Are you sure you want to do this? Yes, because it's a permanent explosion, but if you constrain it correctly, it'll go back to its constrained position. So when I hit Update, everything should go back to where it belongs. And yes, it's constrained. If there was a constraint missing, one of the items would have, or more than one item would have stayed floating out in space, letting you know it's not completely constrained. You're missing some constraints. Okay, let's go on to the next topic. Okay, symmetry. If you want to symmetry some items, okay, we have the symmetry option. To get to symmetry, you got to go to the Insert, Symmetry. There is no icon for symmetry at the assembly level. Okay, so let's say for some reason I wanted to create a mirror image of this end assembly. Let's say I want to create a mirror image on the opposite side. Okay, so let's go to Insert, and once again you have to be in the assembly workbench. Go to Tools, Insert, Symmetry. Okay, so let's say, you know what, I'm going to do a symmetry of the brown strap. Okay, so let's say we wanted to do a symmetry, put it on the other side. Okay, so it's asking me for a plane to symmetry about. I'm going to symmetry about this plane. Now it's asking me select product, or I can select the component to symmetry, and I'm going to select the strap. And it's making a mirror image, as you can see. You can do a mirror, a rotation. You can bring in all the features inside of the part body for the original strap. You can bring in the axes, any geometric sets, any other bodies. Remember, we can insert more than one part body into a part. And you want to keep it linked. So if this moves, this will move in the opposite direction. Okay, so you can, and typically you do want to keep links. And I would just go with the default options and hit finish. And there it is. It makes a duplicate. Close. And there it is. There's a symmetry of the original clamp strap. Now let's say we wanted to do the other features. We want to do a symmetry. Okay, so let's go again. Go to Insert, Symmetry. We'll pick the same plane, same vertical plane. Now it's asking me to select components. So I can select more than one. I'm going to select, hold on to the control key, the fastener. Let's see if it'll let me pick the end. Oh, I can only do one at a time. My mistake. I can only do one assembly or component at a time. And generate. There it is. It generated. Oh, it's missing some of the parts. It didn't generate. And the reason it didn't generate the threaded shaft is because I needed to pick other part bodies. So this is made up of two part bodies. The foot and the threaded shaft are made up of two part bodies. That's the way I downloaded it from Carlane. So I should have picked the other part bodies. So let me go ahead and close and delete. I'm going to delete this new symmetry. Okay, I'm going to do it again. Insert, Symmetry. Select your plane. And select your items. Okay, so we're going to select the fastener assembly. This time I am going to pick other bodies. So it'll bring in also the threaded shaft. And finish. This time it should bring it. Okay. Okay, it seems like I wasn't able to delete it. Let me see, hit update. Gotta find out what went wrong here. I think it was because I had to delete this symmetry 2. Notice there's only one symmetry. Let me delete this symmetry 2 and do it over again. Delete. Okay, so we have the first symmetry. Okay, try it again. Insert, Symmetry. Pick the plane. There it is. Select the item. So the fastener and assembly with other bodies. And finish. And close. Okay, so it did generate the second one. Let me see if I hit update, if it generates it. Update. And there it is. Let me right click update. Okay, so it did generate. Oh, it didn't bring in the nut this time. All right, so let me go ahead and do a symmetry on the next one, and I'll move on, or else I'm stuck here for a while. Okay, so let's go ahead and do a symmetry of the other end assembly, or the other assembly. Insert, Symmetry, pick the same plane. This time I'm going to pick the entire end assembly. I'll leave out other bodies. Actually, you know what? I am going to include other bodies. And finish. And this one did work. Okay, so that is symmetry. Yeah, so for some reason it didn't do the hex nut. It's okay. Just to save time, I'm going to leave it alone. So that is symmetry. And you would have to go to File Save Management, so it saves all these new files. Okay, let's go on to the last slide. Okay, bill of material. Okay, sometimes you don't want something to show up in the bill of material. You can turn this off Sometimes you have parts inside of your assembly that are reference only. So for example, if you didn't want the end assembly to be part of your final bill of material, you can always right click, Properties, go to the Product tab, and you can remove it from your bill of material or parts list. You can uncheck it. So in this case, I do want it, so I'm going to keep it on. So now I'm going to create a parts list or bill of material, also referred to as the BOM or BOM. Okay, so I'm going to go to Analyze, Bill of Material. And again, the default is to have everything checked. So it shows up in the bill of material. And it'll generate a bill of material for me. Okay, so let's go to Analyze, Bill of Material. So it's going to create a bill of material of the whole thing. So make sure this is active, the top assembly. Go to Analyze, Bill of Material. And it generates a bill of material of all the parts and all the sub-assemblies. Okay. And then you can save as. Go to Save As. Once again, click on Save As. And you can save it as a text file. You can save it as a... It's not giving me the option here, but oh, there it is. You can save it as an XLS file, which is a spreadsheet in Excel, or HTML file. I'll save it as an HTML file. And I'll save it as a parts list or BOM, bill of material. And save. And OK. So if I go back to that folder where I have my clamp assembly, here's my file. Let's see if it opens it up. No, I don't think I'm currently connected to the internet, but okay, there it is. So there it is. There's my BOM file, my HTML file, and it opens it up. So this is something you would give over to procurement so you can order the parts and material for your assembly. Let me go ahead and close it. So once again, let me go to that folder and reopen it one more time. Okay, so I have it in my CAD 32 folder, assignments, and clamp assembly. So there it is. It generated a bill of material. Let me view it as details. There it is. So there's my HTML file for BOM or bill of material that it generated or that I saved. And you can also save it as a .xls file, an Excel spreadsheet. Okay. All right, so this is the end of the second lecture.